Hi, today we're looking at Functional Skills Maths Level 2. We've got the NCFE exam board. This is past paper P001841 and we're going to start with the non-calculator section. Activity 1. Fashion Retailer. Matteo is the manager of a large fashion retailer. He works out the profit for a shop. The shop had total income of £7.075 million, total costs of £3.248 million. Work out 7.075 minus 3.248. Okay, so I'm going to do this as a column. So do 7.075 and we're going to subtract 3.248. So we're lining it all up, so we've got our units, so tenths, hundredths and thousandths. We're going to start from the right, so we're going to do 5 minus 8. Well, 8 is bigger than 5, so we can't do that straight away. So we're going to reduce the 7 by 1 to make it 6, and we can give 1 over here to make this 15. So we've now got 15 minus 8, which is 7. We've now got 6 minus 4, which is 2. 0 minus 2, well, we can't take 2 away from 0. So again, we're going to reduce the number by 1 to make it 6 and give 1 across. So now we've got 10 minus 2 is 8. Bring the decimal point down, and 6 minus 3 is 3. So we've got a final answer which we can put in the box of 3.827. 1b. Matteo has this data about the total income and costs in another shop. So we've got the income is 11.5 and that's in £1 million, and the costs are £5.52 million. Matteo uses this formula to work out the net profit margin for this shop. So we've got N equals R minus C all divided by R times 100. Where N equals the net profit margin, so that's what we're working out, and that's as a percentage. R is the income in millions of pounds, and C is the costs in millions of pounds. Is the net profit margin for this shop greater than 50%? Show how you decide. Okay, well, we can put the values into this formula. So N equals, well, R is the income, so that's going to be 11.5. So we're putting that in place of this R here. And then it's minus C. C is the costs, which is this figure here, 5.52. And then that's all going to be divided by R, which was this number up here, 11.5. And then that's going to get multiplied by 100. Okay, so we can do this bit by bit. First thing we want to do is the 11.5 minus the 5.52. Okay, so with this one, I'm lining up. These are our units, decimal point, our tenths. We haven't got any hundredths, so I'm going to put a 0 in there for us. And this is our subtraction. So 0 minus 2 we can't do, so reduce the 5 by 1. And now we've got 10 minus 2, which is 8. 4 minus 5, again 5 is bigger than 4, so we can't do that. So we reduce the 1 by 1 to take it down to 0, and make this 14. That's the 1 we brought across. 14 minus 5 is 9. 0 minus 5 we can't do, so we take the 1 down to 0, but we can now put it here to make that 10 minus 5, which is 5. So we've got, if we put that in here, we've got, this is going to give us 5.98, which is what we just worked out, divided by 11.5, and that's going to be multiplied by 100. Okay, so what can we do with this bit now? Well, we can think, we're trying to compare this to a net profit margin of 50%. So rather than trying to work this out, because this looks like it might get a little bit messy without a calculator, what we can do is go from the other way and say, well, let's work out what a 50% profit margin would look like, and then we can compare it to the values we've got here. So 50% profit margin, that's going to be 50% of our income. So really we want to do 11.5. 50% is half of it, so we're dividing it by 2. So 2 can't go into 1, but 2 goes into 11. 2, 4, 6, 8, 10. 5 times with 1 remainder, decimal point here. And then 2 goes into 15. 2, 4, 6, 8, 10, 12, 14. That's 7 times. Remainder 1. We need to put a 0 here, so we've got somewhere to put our remainder. And then 2 goes into 10. 2, 4, 6, 8, 10. That's 5 times. Okay, so we've got 5.75 here, which is what we would need as our income. Sorry, not as our income. We would need this as our income minus costs if we had a profit margin of 50%. We've actually got 5.98. Well, 5.98 is greater than 5.75. So, yes, it is bigger than 50%. Okay. Might take a little bit of thinking this. So what we're saying is basically to do the full calculation is going to be a bit complicated. I don't want to divide 5.98 by 11.5. So instead what we're saying is, well, let's use the 50%, see what value we'd need to have at the top. We get that that's 5.75 and then compare it to what we had. Okay, 1C. Matteo has this data about the income in the best performing shop. So in January, there was an income of £1.2 million, February £0.8 million, and so on. Work out the median monthly income in this shop. Well, the median is the middle value, but it's not just going to be the middle value here, it's going to be the middle value when they're sorted in order. So what we're going to need to do is put them in order from smallest to largest. So what's the smallest we've got? Well, we've got some that start with 0, so that looks the smallest, 0.8. Then 0.9, then another 0.9. So then we're on to the ones. We've got 1.2, we've got 1.1. Actually, we want, although they're both 2, we're going to have to make 1, 2 and 1, 3. Then that would be the fourth one. Next smallest, we've got 2, 1.2, so 5th and 6th. Then 7th. Then what's next? Then we've got 1.4, we've got 2 of them. So yeah, it doesn't matter which, if we make this 8th and that 9th or the other way round, because it's the values that we're interested in, not the months at the moment. So next biggest one is going to be 1.6, then 1.8, and there's 12 months, so the last one should be number 12. Okay, so what we can do is we can rank them all in order. So we will, if we go number 1 first, we'll have 0.8, then 0.9, third is another 0.9, fourth is 1.1, then 1.2, then 1.2, then 7th is 1.3, 8th is 1.4, 9th is 1.4, 10th is 1.6, 11th is 1.8, and 12th is 1.9. So to find the median, we cross off the smallest and the largest, keep doing that in pairs until we end up with either 1 in the middle, or if we've got an even number of values, we're going to have 2 in the middle. So we then need to add them together and divide them by 2. So 1.2 plus 1.3, 2 plus 3 is 5, 1 plus 1 is 2. So we've got 2.5, but we need to divide that by 2. 2 goes into 2 once, decimal point. 2 goes into 5, 2, 4. Sorry, that's twice. 2, 4, that was my 2. But we've got remainder 1, so we need a 0, so we can put the 1 in front of it. And 2 goes into 10, 2, 4, 6, 8, 10, 5 times. So the median is 1.25. So we can put that in here, 1.25 million pounds. (1D). The fashion retailer made a profit of £525 million in 2020. Matteo will use 8% of this profit as the budget for a new shop. The shop will have a square floor area with side length 40 metres. The annual rent for this shop is £2,000 per square foot of the floor area. Matteo thinks he will use more than 2/3 of the budget to pay the rent in the first year. Is he correct? So we've got loads of information going on there. We want to try and sort of know where to start. Well, to start with, we can look at the budget. He's going to use 8% of his profit as the budget. So we want to work out 8% of 525 million. Okay, so 8% of 525 million. Well, of always means times. So let's do 8 times 525. Okay, we're going to turn it into a percentage afterwards, but we'll keep it like this, keep it nice and simple for now. So 8 times 5, or 5 times 8, we'll have 8, 16, 24, 32, 40. 2 times 8, 8, 16, plus 4 is 20. And then 5 times 8, or 8 times 5, we saw earlier, actually we did 5 times 8 last time, didn't we? 8, 16, 24, 32, 40, plus the 2, got 42. Okay, so we've got 4,200. We want to turn this into a percentage. So instead of 8, it's 8%. So we're going to need to divide this by 100. So we're going to move the decimal point once, twice, or think of it as crossing out the 2 zeros. So we end up with 42 million pounds. That is our 8%. Okay, so that's a good starting point. Now, the annual rent for this shop is £2,000 per square foot. So, we're going to need some way of getting from feet to metres. And what we've got with this question is we do have, on the other side, a graph to convert between metres and feet. So if we move this up here, right. Well, what we had was our square foot. We were told that we've got square floor area with side length 40 metres. So if I do a little square, so that's 40 metres this way and 40 metres that way. So I'm going to use this graph to work out what would 40 metres be in feet. Well, here's 40 metres. So we're going to read up and then across. And that is going to be 110, 120, 130 feet. Okay, so instead of 40 metres by 40 metres, we can think of this as a square, which is 130 feet by 130 feet. So what we can do is work out what the area is of this square. So I'm going to go back to here and work it all out on this bit. So let's just draw it on. Actually, this is my square, 130 feet, 130 feet. So to work out the area, we want to multiply 130 by 130. I'm going to ignore the zeros for now and just multiply 13 by 13. So we can say 3 times 3, 3, 6, 9. 1 times 3 is 3. Now we're on to the 10, so we can put a 0 for the units. 1 times 3 is 3. 1 times 1 is 1. Add these together. 9 plus 0 is 9. 3 plus 3 is 6. 1 plus nothing is 1. But remember, we had a 0 here and a 0 here, so we need to put on those two zeros. So we end up with 16,900, and that's going to be square feet. Now, if the rent is £2,000 per square feet, well, we then want to multiply this by 2,000. Again, though, I'm going to ignore the zeros and put them in afterwards. So we got these zeros here. So in fact, we can carry on here. So we've still got the zeros, but let's work without them. And we know we're going to have 3 zeros here as well. So we can say 2 times 9 is 18. 2 times 6 is 12. Plus 1 is 13. And 1 times 2 is 2. Plus 1 is 3. Now we had 1, 2 zeros there. And 1, 2, 3 zeros there. So let's put some commas in, because I can't work out what this number is at the moment. So 1, 2, 3. 1, 2, 3. We know this is pounds. So we've got 33,800,000. Okay. Now, we don't want to just stop it there, because what we've got is that Matteo thinks he will use more than 2/3 of the budget to pay the rent in the first year. So we want to work out what 2/3 of this is, so we can then compare it to this number down here. So if we want 2/3 of this, let's start off by working out 1/3. In other words, let's divide it by 3. 3 goes into 4 once, remainder 1. 3 goes into 12, 3, 4, 6, 9, 12. That's 4 times. So that's 1/3. Okay, 1/3. We want 2/3, so we're going to double the 14. 2 times 4 is 8. 1 times 2 is 2. So we've got £28 million, and that relates to our 2/3. So let's go back. We've done all the calculations. We've just got to make sure that it all makes sense. So we had Matteo will use 8% of the profit, which we worked out. We worked out how much it was going to cost. He thinks he'll use more than 2/3 of the budget. We know that 2/3 of the budget is 28 million. And we're just saying, well, we've got this number. We could write it in millions if we want. In fact, if we divide it by a million, that means we take off 1, 2, 3, 1, 2, and then move the decimal point in. That's going to be 33.8 million. So we can say 33.8 million is greater than 28 million. So is he correct? Yes, he is. He thinks it'll be more than 2/3. 2/3 is 28 million. It actually cost 33.8. Part 1E. Stock is delivered each month. The table below shows information about the average number of days deliveries took in March and April. Okay, so in March there were 107 deliveries that took between 1 and 3 days, and 84 in April that took the same time. 96 deliveries in March that took between 3 and 5 days, and 33 deliveries in April that took between 3 and 5 days. Okay. Which month is more consistent? Show how you decide. Well, if we're looking at consistency, well, then we're looking at the range. So that's how much the values vary. So we want the range. And the way we calculate the range is by finding the biggest and subtracting the smallest. Well, for March, the biggest is 107 and the smallest is 43. So 107 minus 43, 7 minus 3 is 4. 0 minus 4 we can't do, so reduce that to 0, make that 10. 10 minus 4 is 6. So we've got a range of 64 for March. And for April, the biggest is 127 and the smallest is 33. So 127 minus 33. 7 minus 3 is 4. 2 minus 3 we can't do. Reduce that to a 0, make that 12 minus 3, which is 9. So we've got ranges of 64 and 94. This is the smallest one. So which month is more consistent? Well, it's going to be March. And we can put 64 is less than 94. One F. 10 in every 10 customers of the fashion retailer are loyalty club members. Write 10 over 16 as a percentage. Okay, so we want 10 divided by 16 here. So we can do this like we would with a lot of divisions and do it using the bus stop method. Okay, so you would have the 10 inside the bus stop and 16 on the outside. Might look a bit strange this way, but we'll try it. Well, 16 can't go into 10 because 16 is bigger than 10. So we're going to have to carry the 10 across. So we're going to have a 0.0. And if we put the 10 across, we end up with 100. So we need our decimal point here. So we're saying how many times does 16 go into 100? Well, let's try our 16 times table. Well, 16, add another 16, or 6 plus 6 would be 2. Carry the 1, and a 1 plus 1 plus 1 would be 32. Let me show it here. So we're adding on 16. Add on another 16. 6 plus 2 is 8. 3 plus 1 is 4. Let's add another 16. 8 plus 6 is 14. Carry the 1. 4 plus 1 is 5. Plus 1 is 6. Add another 16. 4 plus 6 is 10. 6 plus 1 is 7. Plus 1 is 8. So we're going up our 16 times table. Let's add another 16. 0 plus 6 is 6. 8 plus 1 is 9. Okay, so, well, 96 looks like it's the closest we're going to get to 100. So that was 1, 2, 3, 4, 5, 6 times. And from 96, 97, 98, 99, 100. So we've got remainder 4. So we're going to put another 0. So we want 16s into 40. Well, we can use this now. 2 16s are 32. So it goes twice. And from 32 to 40, 33, 34, 35, 36, 37, 38, 39, 40. That's remainder 8. Then we want 16s into 80. Well, we've got 80 here. 1, 2, 3, 4, 5 times. Okay, so we've got it 0.625. We want it as a percentage, so we want to multiply that by 100. So 0.625 times 100. We're going to make it bigger by moving the decimal point once, twice. So we get 62.5%. And that's the end of the non-calculator section. Okay, so now we're on to the calculator section. Activity 2, gym. 2A, Nikki needs to renew her gym membership. She sees this offer. Annual gym membership, £685.95. Pay now and get 16% off. Nikki thinks the monthly cost of the gym membership with this offer is £49.95. Is she correct? Okay, so what we're going to do is take 16% off of this and then turn it into a monthly amount by dividing by 12. So let's work out 16% first of all. So we want 16 out of 100 times 685.95. And we've got the calculator now. So 16 divided by 100 gives us 0.16 times 685.95. And we get £109.75, because it's decimal, it's money, so it's going to be 2 decimal places. So 75, the 2's less than 5, so we're just going to stick at 75. Right, so that was 16%. We want to take that off. So we're going back to the 685.95 and then going to subtract 109.75. So 685.95 minus 109.75 gives £576. Well, it's 0.2, but it's money, so we're going to have to make that 20. Okay, that's for the whole year. We want it monthly, so we're going to divide that by 12. And we get £48. Again, we want it money, so we want 2 decimal places, 0, 1. But this is bigger than 5, so it's going to be £48 and 2p. Well, that is not equal to 49.95. So is she correct? No, she's not. Okay, 2b. Nikki uses a fitness studio in the gym. The floor in the fitness studio is made up of a rectangle here and a semicircle. The diagram shows the dimensions of the floor. Good. So we can move that up then. Right. Calculate the perimeter of the floor in the fitness studio. Use pi equals 3.14. Give your answer to 2 decimal places. So the perimeter is the distance around the outside. So we've got this length, this length. This length here is going to be the same as that one. So then we just need this here. Well, what we can do is we can use the circumference of a circle. And the circumference is calculated as, well, either pi d, or you might know it as 2 pi r. But we've got the diameter here all the way across, this 8.45, so we're going to use this version of the formula. So pi is 3.14, and d, so this is the diameter, 8.45. So 3.14 times 8.45, that's 26.533. That's the circumference of a full circle. Okay? Full circle. We want just a semicircle, so we're going to need to divide that by 2 to give us 13.2665. So then we can add on these lengths. So we can add on 12.75, add on another 12.75, and add on this 8.45 here. So if we add all of those, we get 47.2165. They've asked us to give the answer to 2 decimal places. There's 2 decimal places, so we look at the next digit. It's more than 5, so we're going to round that up to 47.22 meters. (2C). Nikki does yoga in the fitness studio. The diagram shows the rectangular space each person doing yoga needs. So 2.4 meters by 2.1 meters. Nikki thinks that the rectangular part of the floor in the studio can fit in at least 16 people doing yoga. So we're going to fit lots of these yoga mats, like this. We might want to put them different ways, it doesn't matter, but they're all going to fit in here, something like that. Okay, and the question just says, is she correct? So what we want to do is work out the area of these mats and the area that we've got down there. Now, what we might want to do, and actually we probably should, is make sure it's not just the area, it's about the size and like which direction they could go. So, because you might have the overall space, but depending on how you lay the mats, it could stop them fitting in. So what I'm going to do is look at one dimension at a time. So see how many of these 2.1s could we fit down this way. So in other words, we want 8.45 divided by the 2.1. And if we did that, we get 4.02. So basically we can fit 4 mats down this way. So we're saying 1, 2, 3, 4 would fit on the floor with a little bit left over at the bottom. How many could we get going across this way? Well, that's going to be 12.75, the full length here, divided by 2.4, which is the length of each yoga mat, I'm guessing. 12.75 divided by 2.4, and it's 5 point something. Now the something doesn't matter because we've got to have whole numbers of spaces, but basically we can fit 5 of these in. So 1, 2, 3, 4, 5, and a bit left at the end. Okay, so if you imagine the whole floor is going to look like this with a bit at the end and a bit at the bottom. So we can count them up. 1, 2, 3, 4, 5, 6, 7, 8. Or we can say, well, we got 5 times 4. So we can fit 20 in. She said at least 16. Well, 20 is more than 16. So is she correct? Yes, she is. As long as it's 16 or more, she's right. Okay, 2D. Nikki uses a treadmill at the gym. The screen on the treadmill displays the scatter diagram with information about her last 16 workouts. Okay, so we've got time going up, average speed going across. So if we pick, let's pick this value here. So it's halfway between 5 and 6. So this is saying at an average speed of 5.5 kilometers per hour, she lasted 80 minutes. Yeah. Okay, so 80 minutes at a speed of 5.5 kilometers per hour. Or a value down here. This one she was going at 8.5 kilometers per hour, and she was doing that for 20 minutes. What distance did Nikki run in her 20-minute workout? Well, actually, we've sort of done some of that already. So the 20-minute workout, we read across. Oh, slipped. Is that value there? And it's halfway between 8 and 9, so we can say that's 8.5 kilometers per hour. Okay. Now, if it's only 20 minutes, well, we've got 20 minutes out of an hour, so it's part of an hour. 20/60ths of an hour at a speed of 8.5 kilometers per hour. So if we multiply that all out, well, if we do the 20 divided by 60, you'll see, well, that's a third. So a third of an hour times 8.5, and we get 2.83333. That's going to be kilometers. They want the answer to 1 decimal place. That's 1 decimal place. That's less than 5, so we can forget about that. So it's just going to be 2.8 kilometers. 2E. The diagram shows the side elevation of the treadmill. Okay, so they're running on a bit of an incline. Calculate the size of the angle labelled A, this one here. Well, we've got this angle, 76 degrees. We've got this one, a right angle, which we know is 90 degrees. And we know that the total degrees in, well, this is a triangle, in a triangle, are 180 degrees. So if we add these two together, 90 plus 76, we get 166 degrees. So if we then subtract that from 180, we get 14 degrees. Okay, 2F. Nikki sees these results of a survey among the gym members. Okay, so it's got age groups of 18 to 24-year-olds, 25 to 49-year-olds and 50 plus, and what type of diet they're on, either a low-carb diet, a balanced diet, or a vegan diet. What is the probability that a gym member chosen at random, so any of these, is aged 50 or over, so we want the 50 or overs, and is on a balanced diet. So, and on a balanced diet. Okay, give your answer as a percentage. So we need to know how many people we've got in total, first of all. So let's do some totals here. So let's add these up. 9 plus 17 plus 5 gives us 31. 24 plus 46 plus 18 gives us 88. And 3 plus 27 plus 1 gives us 31. So now if we add these all together, so 31 plus 88 plus another 31, we get 150. So our probability is going to be out of 150. Now we said it was someone aged 50 plus, so here, and on a balanced diet, so we're looking at this where it overlaps. So it's going to be 27 out of 150. To make it a percentage, we're going to multiply it by 100. 27 divided by 150 times 100, and we get 18%. Activity 3, wind power. Last year, and to read this number, I'm going to count 1, 2, 3, put a comma, 1, 2, 3, put a comma, 1, 2, 3, comma. So we've got thousands, millions, billions. So last year, 119 billion kilowatt hours of the energy generated in the UK came from renewable sources. Write in words. Okay, so I already said this would be thousands, this would be millions, this would be billions. So we've got 119 billions. So 119, so literally counting what's that number before all of the zeros, and then we've got 9 zeros, so that's going to be 119 billion. Okay, 3B. Last year in the UK, 47% of the total energy came from renewable sources. 54% of the energy from these renewable sources came from wind power. What percentage of the total energy generated in the UK last year came from wind power? Okay, so 47% of the total was from renewable, and then 54% of this was wind power. So we want 54% of 47%. Okay, so you can think of that, well, 54% would be 54 out of 100 of 47, of always means times 47, and that's going to be in percent, so that should be fine as it is. Sometimes if you're not sure, oh, do I need to add zeros or take them off to get the percent, do the calculation first. So if we look at this one, so 54 divided by 100, so that turns it into a decimal, times 47, so that's giving us 25.38%. So that sounds sensible. Okay, and we can write that in our answer box, 25.38. If you want to do a check, you can say, well, it's sort of, this is about a half, and then we've got half of a half. Well, half of a half is a quarter, which would be 25%. So we're pretty close. 3C. Gustav works on a wind farm as an engineer. He looks after 9 wind turbines. The table shows information about the energy produced by each of the wind turbines in 2019 and 2020. So we've got one entry for 2019 and another for 2020 on each of the turbines. Gustav thinks that on average, the wind turbines produced more energy per turbine in 2020 than in 2019. His manager disagrees. Show that both could be correct. Well, the only way that both of them could be correct is if we're looking at 2 different types of averages. So we're going to need to look at the mean and the median. Okay, now we will want to, let's move this up a bit here, and then I'm going to show what we're after, because we're going to want to have our, we can still keep our 2019 and 2020, and then we're going to have our mean and our median. So I'm just going to turn this into a little table. This is where all of our results are going to go. So we're expecting the median to be higher for one of them and the mean to be higher for the other. Okay, so let's start off well. For the mean is calculated as the total divided by the frequency. So we're going to want the total for each of 2019 and 2020. So let's work these out. So we've got 5870 plus 6140 plus 5940 plus 5980 plus 6190 plus 6310 plus 6235 plus 6200 plus 5919. You've got to be really careful with this. It'd be so easy to type the wrong thing in. So we've got 54,855. And let's do the total for 2020 as well. So 6,200 plus 5980 plus 5,820 plus 6,005 plus 6,210 plus 6,220 plus 6,195 plus 6,240 plus 5,940. And for this one we get a total of 54,810. So we can work out the mean, because for 2019 it's going to be 54,855. So this total here divided by, well, we've got 9 turbines for each, so divide it by 9. 54855 divided by 9. We get 6,095. Okay, now let's work out the mean for 2020. So it's going to be 54,810 divided by 9. And we get 6,090. Okay, so they're very close, but it is slightly higher for 2019. Now for the median, we're going to need to rank each of these. So we want the smallest first of all, so 58. Anything smaller than 58? No, so that's going to be 1. Then 5940. Then 5980. 5990. What's next? 6140. 6190. 6200. 6235. And then finally 6310. Okay, let's do the same for 2020 and then we'll work out the median for both. So what's the smallest one here? 5980 or 5008? Yeah, that's the smallest. Then 5940. 2. Then 3. Then we got 6005. 6200. No, we got 6195 smaller. Then 6200. Then 6210. 6220, finally 6240. Now, quite often what we do is we write them out from smallest to largest and pick the one in the middle. But what I'm going to show you is if we've got 9 turbines, then imagine that these are what we've got. We've got them ranked from smallest to largest. If we cross off smallest and largest and keep going, we're going to end up with the middle one, which is the 5th one. And the 5th one for 2019 was 6140. And for 2020, the 5th one is 6195. Okay, so we've got the mean for both, and which one's bigger? The mean is bigger in 2019, and the median is bigger in 2020. So it says show that both may be correct, and they were saying that they generate more energy. Well, we've shown it, but if we want to, we can just say mean is higher in 2019, 6095 versus 6090, and median is higher in 2020. And there we've got 6,195 versus 6,000. Oh, it's the median we're comparing, so 6,140. (3D). The wind turbines cannot work if the wind speed is 55 miles per hour or greater. Gustav reads this forecast for Friday. There is a 35% probability that the wind speed will be 55 miles per hour or greater. What is the probability that the wind turbines can work on Friday? Give your answer as a decimal. So they can't work if they're 55 or more, and the probability of that is 35%. So the probability that they can work is going to be 1, or think of it as 100%, minus 35%. So 100 minus 35 is 65%. And if we want to turn that from a percent into a decimal, we just divide it by 100, which gives us 0.65. Okay, 3E. The wind turbines are placed along a line. The diagram shows the distances between the turbines. Okay, 92 metres, 95 metres, so on. Gustav puts a new turbine next to the last turbine along the same line. Okay, so I think they mean they're going to put one here. The distance between the last turbine and the new turbine, so this distance, is 3% greater than the modal distance between the current turbines. Gustav shows the last turbine and the new turbine on a scale drawing. The drawing uses a scale of 1 to 2,500. What is the distance between the last turbine and the new turbine on the scale drawing? Give your answer in millimetres. Well, first we're going to work out what the distance is in real life. Okay, and to do that, we need to know what the modal distance is. In other words, which one occurs most frequently. Well, 92, we've only got 192. So we can put one of those. 95, we've got 1, 2, 3. So we've got 3 95s. 93, we've got 2 of them. 94, we've only got 1. 97, we've got 1. So the modal distance is 95 metres. And we want to increase that by 3%. So we want 3 out of 100 times 95. That's going to tell us what 3% of 95 is. 2.85. Then we just want to add on the original distance, the 95, which gives us 97.85 metres. Okay, that's the actual distance. At this point you could round it maybe, because they've got all of theirs to round metres, but I don't need to. I'm going to leave it like that. Okay, so what we can do next is we can say, well, first of all, let's work this out in millimetres, because they're talking about millimetres here. We've got metres, so let's turn it all into metres first of all. So I know that there's 100 centimetres in 1 metre, so we're going to do 97.85 times 100. Still got it in my calculator, which means we've got 9,785 centimetres. And I also know that there's 10 millimetres in 1 centimetre. So 9785 times 10 gives us 97,850 millimetres. Right, so that's in real life. That's how many millimetres it is. Now, we've got this scale drawing here. So let's draw a ratio table. So the ratio that they've given us is this 1 to 2,500. So what we can say is we've got the distances on the drawing, and then we've got the distance in real life. Let's use the ruler here. And they're telling us that for every 1 on the drawing, it's 2,500 in real life. Okay, it doesn't matter 2,500 what, so long as the units are the same. Now we know that in real life, we actually want 97,850. So we're trying to find, well, what is that measurement on the drawing? And the way we do that is say, well, how do we get from 2,500 up to this value? So we've got to go backwards. So we've got to say 97,850 divided by 2,500. Still got that in my calculator. Divide by 2,500. And that's telling us that we're multiplying by 39.14. So we're going to do the same over here. But because it's by 1, well, 1 times that is still going to be 39.14. And that's the number of millimetres that it would be on the drawing. Okay, 3F. I might have to move this down to see all of the question. The diagram shows the foundation for the new wind turbine. Okay, so we've got this here, sort of 3D shape. They've used this paper to show it. The foundation will be a hexagonal prism. It's a hexagon here, and it's the same shape all the way up, with a base of 4 meters. Okay. Gustav uses a coordinate grid to indicate the center of the foundation for the new turbine. Each small square on the grid represents a square 1 meter by 1 meter for the foundation. He wants the center of the foundation to be at 3 minus 2. Let's move it up so we can see what they're talking about. On the grid, draw a plan view of the foundation in this position. Right. Well, they've told us where the center is, 3 minus 2. So let's draw that on here first. So 3, we go along 3, and then down to minus 2. So that is going to be our centre. And they've told us that it's got a base of 4 metres. And each of these squares is 1 metre by 1 metre. So if it's got a base of 4 metres, we're going to go 1, 2 that way, 1, and then 1, 2 that way. So 4 metres across that way. And what we can also do is go 1, 2 up that way, 1, 2 that way. Okay, right, so we kind of know that's our centre, but we've got to look at this hexagon, okay? So we can see it's 2 across. Now it's quite hard, it doesn't necessarily look like 2 down here because it's this, the funny graph paper. So what I'm going to do is I'm going to focus on drawing these 2 across here, these 2 across here. And the way I'm going to do that is say, well, let's treat this point as being in the middle. So my 2 is going to be like that. And this one down here is going to be the same. And then we can use this point to then connect it and draw our hexagon. Okay, and that should be the same as this up here. Show that one again. Okay. Activity 4. New bathroom. Ola wants a new bathroom in her flat. She estimates the total cost of the new bathroom to be £6,500. Ola put £4,200 in a savings account exactly 3 years ago. The savings account paid an annual compound interest rate of 1.6%. Ola will use the £4,200 plus the interest paid after 3 years for the bathroom. She will borrow the remainder of the total cost. How much does Ola need to borrow? So in short, what is £4,200 worth 3 years later with this interest rate? And then what's the difference between that value and £6,500? So when we're doing compound interest, what we need to do is turn this 1.6% into, well, we want to turn it into a decimal first of all. So we divide it by 100. So we get 0.016, and then we add 1 to it. Now, the reason we're adding 1 to it is because then when we multiply this, this is basically equivalent to 101.6%. So instead of just multiplying by 1.6% and find out what the interest is, by multiplying by 101.6%, we're going to find out what the new value is. So it's the initial amount plus the interest, doing it all in one go. And that means that when we do 4,200 times 1.016, this value will tell me what it's worth after 1 year. So if I want to know what it's worth after 2 years, I multiply by the same amount and the same again for 3 years. If you had a scientific calculator, you could put 1.016 cubed, but you can do it on a simple calculator easily. So let's work this all out. So we've got 4,200 times 1.016. So that's what the amount has grown to with 1.6% of interest. If we multiply by 1.016, it's added on an extra 1.6% interest. But it's also added interest on the interest that we earned in the first year. Now, if we want to know the value after 3 years, we do it one more time, 1.016. We get 4,404. We want 2 decimal places, so 84. The third digit is a 2. It's less than 5, so we can just leave it like that. Okay. So that's what the value has grown to. We want the difference between that and how much they need to pay for the bathroom. So 6,500 minus £4,404.84 will give us the answer we want. 650 minus 4404.84, which is £2,095.16p. Okay, so 4b. Ola buys a new bath. The bath is in the shape of a prism with a vertical cross-section in the shape of a trapezium. Okay, confusing. So prism, the prism means that we've got a shape here, which happens to be a trapezium, and it's the same shape all the way through. Okay, and we've got some measurements on here. We've got the A is the distance across, B is that distance across here, W's how far back it's going, and D, we've got the depth of the water. Ola uses this formula for volume, V, of water in the bath. Okay, I'm going to move this up. And we've got that V equals D, and then it's next to A plus B, so that means we've got a multiply sign in there. All divided by 2, and then multiplied by W. Okay, where D is the depth of the water, that here. A is the length of the water surface, across there. B is the length of the bottom of the bath, here. And W is the width of the bath, going back that way. Okay. Right, this one can be confusing because we've got to look at the other page at the same time. The bottom of the bath has length 120 centimetres. So what I'm going to do is I'm going to write that on here. So this is 120 centimetres, okay. And width 75 centimetres. Okay. The length of the water surface is 150 centimetres. So that's 150. When the bath is filled, to the depth of 50 centimetres. So D equals 50 centimetres. Okay. The tap in the bath has a water flow rate. So let's draw my tap. This is going to be a terrible tap. It doesn't look anything like a tap. I don't know what I'm doing there. But the water's coming out, okay? And that flow rate is 15.1 litres per minute. Work out how long it will take Ola to fill the bath to a depth of 50 centimetres. Give your answer to the nearest minute. Okay, so now we can go back to this because we've got all our measurements written on. We've got our formula. So let's just put it in. So D, we've got D is 50. So it's going to be 50 times. Then we need A plus B. Well, A is 150 plus B, which is 120. And all of that is divided by 2. And then because W is just at the end, it means, again, we've got an invisible multiplier there. And the W is 75. Well, let's do this bit first, because it's in brackets. So we've got 150 plus 120, which is 270. So we've got 50 times 270. Then we're going to divide that by 2. Okay, so all of this is coming out at 6,750. And then we're going to need to multiply it by 75. Which gives us 506,250. Okay, now that's the volume. So that's centimetres cubed. We want to turn it into litres. So we're going to need to divide that by 1,000. Which gives us 506.25 litres. Okay, now, if the flow rate is 15.1 litres per minute, how many 15.1s go into this? So in other words, 506.25 divided by 15.1, which is 33.52649. They want the answer to the nearest minute. Well, that's our minutes. So we look at the next digit. If it's 5 or more, we round up. So it's going to be 34 minutes. It's quite a big question there, but it's quite nice really. If you're just substituting your values into the formula. This is the bit you do need to know. To go from volume to litres, you need to divide by 1,000. And also it's good to kind of think it through. If you've got a bath, how long do you expect a bath to take to fill? Well, anything from, 15 minutes to 35, 40 minutes. So this looks in that sort of range. Okay, 4C. Ola wants to cover the bathroom floor with tiles. The diagram shows the shape and the dimensions of the bathroom floor. So we've got some measurements on here. One box of tiles covers 0.56 meters squared of the floor. How many boxes does Ola need to buy? And this is for 4 marks. So what type of question is this? It's an area question. We want to work out the area. Now we've got 5 sides, so it's a pentagon. I don't know an easy way of working out the area of a pentagon, so what I'm going to do is I'm going to split it up into a rectangle, and then, I've got a trapezium down here. So this shape up here, the area is going to be the length times the width, so 3.8 meters times 3.1. So 11.78. That's going to be meters squared. Now this is similar to the formula we used before, where we want, if this is A and this is B, and we can call this H. We want A plus B divided by 2 multiplied by H. The only difference last time was we had a 3D version of it, but this is what we want. So we need our A and our B. A is this full distance, which is 3.8 meters. We're going to add that to this distance here, which is 1.95. Then we're going to divide it by 2. And multiply it by this height. Well, we haven't got this height, but we have got the full height and this bit here. So it's going to be the difference between these. So it's going to be 4.65 minus 3.1. Which is 1.55 meters. So now we can work this out. Well, actually, let's do like last time. Let's work out the bit in brackets first. 3.8 plus 1.95 gives us 5.75. Then we're going to divide that by 2. And then multiply that by 1.55. 4.4625. That's area, so that's meters squared. That's just this bit down here. We need to add them together. So the total area is going to be the 11.78 plus the 4.45625, which gives us 16.23625. Okay. One box of tiles covers 0.56 meters of the floor. So we want to divide this by 0.56 to tell us how many boxes we're going to need. And if we do that, we get 28.99 blah blah blah. So we're going to need 29 boxes. Okay. 4D. Ola hires a builder to tile the bathroom floor. It would take one builder 1.5 hours to tile the floor. How many hours will it take 3 builders working at the same rate to tile the floor? Okay, well, if that's for one builder, 3 builders should be quicker. So definitely don't multiply it, because you'll end up with it taking longer with more people, which doesn't make sense. So if you've got 3 people, we need to divide it by the 3. So 1.5 divided by 3, and we get 0.5 hours, or half an hour. Okay. And the final question, 4E. The diagram shows a sink with a stand. And this is the front view, so looking that way. This is the back view, and we're sort of looking, I suppose, sort of like down onto it. Draw a plan view of the sink with the stand and a side elevation of the sink with the stand. Now they've given us 2 different sections there, so we can do the plan view first. So the plan is going to be looking straight down on it. Now the thing to note, they haven't given us any measurements. So it's always going to be a bit of a sketch, okay? It's not going to be 100% accurate. But you still want to use your ruler. So if we were looking straight down on this, we wouldn't see any of this at all. All we would see is a big rectangle. So it's up to us how big we want to do it. It's definitely a rectangle. So I think I'll do it, let's do it 6 squares down. And let's say 8 across. 2, 4, 6, 8. But what you probably see is that you've got this ridge at the top. So what I'm going to do is I'm going to go in 1 square, because again we don't know exactly what the measurements are, but we know it would be something like that. So that's my plan view. Seems reasonable. Now we want the side elevation. So the side is going to be kind of looking from this side here, or you could think of it as looking from this side. So you're going to have this bit on top and a stick coming down underneath. So the bit on top, well, we've said that it was 6 across. So maybe we can say, well, if we start there, let's go 2, 4, 6 across there. So this length is the same as that length, because that's where we're looking at. Okay. And we can see that it goes in a bit. So we don't know how high it is. Let's say maybe it's going to go down 2 squares and in 1. So it's not quite guesswork, but we do have to use our imagination a little bit. So that is what I think this top bit is going to look like. Then we've got the pedestal, this stick bit here. Now, for me, it looks like it's closer to the back than it is to the front. Now, in the answer book, it's got it right in the middle. I think they'd let you have it either way. So I would put this one on. And again, the actual length of it we don't know, but we can go for, I don't know, maybe 5 squares. But I'm going to have it slightly closer to the back. So 2, 3, 4, 5. And that's going to be my side elevation. Okay. So plan view, looking straight down on it, that's all you'd see. Well, you'd probably see a drain in the middle somewhere, but they haven't shown us that, so we can't put it on. And from the side, that would all we'd see as well. So that's the end of the paper. Hope you found it helpful. Please like the video, subscribe to the channel, add any comments, ask any questions, and I look forward to seeing you again soon. Thank you.